Welcome, soil conservation and management students, to our 6th video lecture as part of our Session 13 lecture series on soil resilience. These lectures have been developed for the Soil Conservation and Management course at the Royal University of Agriculture in Phnom Penh, Cambodia. And I am Dr. Jared D. Williams with Brigham Young University, Idaho, in the United States of America. We've given 5 previous video lectures on concepts, importance, and other topics related to soil resilience. And this video lecture number 6, we are going to talk about indicators and management strategies for soil resilience. Let's begin by talking about indicators for soil resilience. Indicators of soil resilience are going to be soil properties that help determine or identify changes that are occurring in the soil. Remember, soil resilience is the ability for the soil to bounce back. So, properties or soil properties that help us identify changes in the soil will also be properties that will help us understand or indicate soil resilience. Also, factors that help us understand soil formation processes will also aid us in understanding soil resilience. We've broken down these indicators by physical, chemical, and biological properties. So again, chemical properties here in green, chemical properties in orange, and where's my purple, and biological properties in purple. Physical properties. Again, remember, we are identifying properties of soil that will indicate either deep soils or fast soil development. Okay. So, soil horizonation. This is the development of soil horizons. Oops, wrong color. This is the development of soil horizons. So, if soil horizons are developing quickly, that indicates a high soil resilience. Bulk density and porosity. Again, soil organic matter and microbial activity are going to be key to soil resilience. Lower bulk density and higher porosity are going to be indicators of high soil resilience. Aggregate stability. Similar to bulk density and porosity, aggregate stability reduces soil erosion and promotes healthy soil organic matter levels. Higher aggregate stability will result in higher soil resilience. Same with water infiltration and capacity. Chemical properties. Soil pH. Soil pH will often indicate, let me restate that. Soil pH in an ideal range between a pH of 5.5 and 7.5 or 8, so between 5.5 and 8, will result in good, healthy soil for plant growth and microbial decomposition. Outside of that 5.5 to 8 range, plant growth will be reduced and microbial activity will be reduced, resulting in less or lower soil resilience. Essential nutrients, soil organic matter, and cation exchange capacity all will help promote soil microbial and activity and plant growth, thereby increasing soil resilience. So, more essential nutrients, higher soil organic matter, and an ideal cation exchange capacity will increase soil resilience, whereas low nutrients and low organic matter would result in a low soil resilience. Biological properties. Biological properties such as microbial biomass diversity, microbial activity, will increase soil resilience. More diversity means we have organisms, or we have what we call functional redundancy, meaning there are multiple organisms that can perform the same task. Even when I have soil disturbance that may kill off a portion of my microbes, I have other microbes that can perform those same tasks, allowing the soil to bounce back or recover. Okay? Vegetative biomass and biodiversity, all of these add to and improve the soil resilience. More biodiversity, more microbial diversity, more microbial activity, more vegetative biomass, all encourage and promote soil resilience. Let's talk about some management strategies that promote soil resilience. Obviously, we've talked in the past about soil conservation and how we want to conserve soils. Here we're thinking about ways that when we have an erosion event or other problems, soil disturbances, what are some of the practices that we can have that will make the soil recover quickly or be more resilient to these disturbances? One of the keys, of course, is soil organic matter. Increasing soil organic matter will increase soil resilience. So what are some practices that we can use that will increase soil organic matter? Okay? We have to consider our farming practices, our land use practices, and our attitudes towards improving soil. Attitudes could be reducing farm income slightly to promote soil health. Obviously, by increasing our sustainability of our soils, by making them more resilient, we will also increase our income over a longer period of time. Okay? Farming practices. What are our crop rotation? What are our tillage management practices? What are our cover crops and other components of our crop rotation and our cropping system? And how can we choose crops that will both provide economic benefit but also improve our soil resilience, so that if we do have a soil disturbance event, that soils can recover. Some of these practices include conservation tillage and no-till, which we have talked about in previous slides as practices of conservation agriculture. We also want to discuss natural fallow and the benefit of using natural fallow systems. Natural fallow is an example here, where we allow for the soil to go back into a more natural state, allowing native vegetation, grasses, shrubs, and trees to grow on the land for a period of time, and allowing the soil to recover. This will increase the soil resilience of the soil. I have 3 management practices as examples. 2 of them come from Brazil on soils similar to those in Cambodia, and a 3rd example from Bangladesh. The first practice will be conservation tillage, followed by crop rotation, and then finally by natural fallow. So an example of a management practice that has increased soil resilience in Brazil is cover crops, and using cover crops. Cover crop system, the cover crops they have been using are pigeon pea and sun hemp, which were both presented by students recently in their papers they submitted as part of our cover crop system. By using these cover crop systems, we're increasing the biomass. Also, we are increasing the soil organic matter and soil fertility of these highly degraded soils in central Brazil. These are ways of being able to provide an increase in that soil organic matter. Both of these examples, pigeon pea and sun hemp, are plants that produce a lot of biomass very quickly with little nutrient input, therefore contributing significantly to the soil organic matter and soil organic matter content within the soil. The second example is a no-till system in Brazil. The no-till system used in combination with a cropping system that used cover crops. So oftentimes a no-till or conservation tillage system is not sufficient to increase soil resilience, but no-till or conservation tillage systems in combination with cover crops could have a greater could increase soil resilience. Now, depending on our soil type, no-till can improve soil resilience. In Brazil, they found that no-till in combination with cover crops did. So they used crops such as oats, cover crop of oats, then their cash crop of corn, then a cover crop of vetch, followed by a cash crop of corn, and then oats and vetch as cover crop, followed with a cash crop of corn, followed by cowpea. We have a picture of many of these crops. Here is cowpea, oats, and vetch with corn. Again, a cropping system that uses a combination of tillage practices and cover crops has an advantage and will significantly increase soil resilience. The last one is natural fallow. In Bangladesh, they allowed soils to return to natural vegetation. So after having cleared the land, they let the land go back by planting in some natural vegetation. The result was a decrease from 18 megagrams of soil per hectare loss via soil erosion to only 3 milligrams of soil loss per hectare per year on the natural fallow. The idea here is that the soil can be allowed to go back to natural fallow for multiple years before return to a cropping system or to crop production. Doing so allows for the soil to build up resilience and has many other benefits in increasing soil organic matter, nutrient availability, and fertility, and reducing erosion. In this lecture series, we talked about the concept and importance of soil resilience, classifications of ways we classify soil resilience, the effect of soil disturbance on soil resilience, factors such as the 5 soil forming factors on soil resilience, and the 4 soil forming processes on soil resilience. We also talked about how erosion affects soil resilience and concluded with some indicators of good soil resilience and management practices. There are also some questions here at the end for you to answer to confirm that you will understand the topics discussed in the 6 video lectures on soil resilience. Again, the key of this lecture is to help us understand how we can make soils more resilient to soil disturbance so that we prevent soil degradation.